com.
So this is real, right? It's not me. It's like marketing. I guess it's approved. I don't know if someone else is going to get in trouble for this or not. But hey, welcome. Welcome to building and maintaining internet scale application with Windows Azure websites. You just need to be able to scale your lungs just to be able to sail this. My name is Yochai Kiryadi. I'm a program manager working on the Windows Azure website team. Been working for a little bit over 2 years on this, and we're so happy. Really, you see, smiling? So happy to get a GA. So we're like, woohoo, we're done, almost, for today at least. So we have a very, very busy day, or an hour, or 59 minutes, basically. We'll have only one marketing slide, I promise. We'll talk a little bit what does it take to run a production site. Whether you need to develop a development cycle, deployments, monitoring it, diagnosing any issues, debugging, yada, yada, and then obviously we'll talk about scale. So with that in mind, not really a long agenda, but extremely long session, demoing scale takes time. And the reason it takes time is because you need to build up stuff. If you want to show some fancy graph like this is a capture from New Relic, which you can see like CPU usage and throttles and throughputs and all that fancy stuff over here. So it takes time because you can see on the next slide, this has been running for a while in order to get like 15K or 10K requests per minute and so forth. So we don't really have a lot of time. So what I'll do, and it's the first time that I'm actually trying to do this, is we're going to run demos while we talk on some other stuff and let the demo run and bake, and then we can see it in later. So it's a kind of a Martha Stewart show. It's like, hey, here's how you build all the ingredients. Let me put it in the oven, and then let me take it out. But I'm actually going through all the motion with you guys. So to start with, we're going to have those 4 scale tests and runs during this session. We're going to run them in twice. Sorry, we're going to run each one of them one, but we're going to run the first 2, and then we're going to break, and then we're going to run the other 2. So the first one will be a way how to show we can scale up. We'll put a load against a site. We'll start with a small one. We'll add medium, and then we'll switch to medium, and then we'll switch to large on the websites. And then we'll actually do something for scale out. Instead of scaling through in and out, we'll just have 3 mediums and we'll bombard them with whatever we can from the infrastructure. So what I have basically is, and I need a volunteer, so I'll get it right in a second. What I got basically, I got several ISVM running in certain DCs, data centers around the world. This one is in Hong Kong. And what I'm going to do, basically, I'm going to use this to run my load. My notes tell me that I'm rushing a little bit, so let me just take a step back. So what are we going to do? I'm going to run a load against this site, or something similar to that. This is a Sudoku solver site, thanks to Adam from our sister team of Build a Portal. He created this Sudoku solver. You click on this, you give him a Sudoku problem, and he solves it in that amount of time and so forth. Not all Sudoku problems are equal. Apparently, you can have bigger Sudoku issues, which takes a little bit longer to solve, and so forth. So this is clearly a CPU-bound problem, rather easy to scale. So I took this, and instead of doing all the fancy graphics and everything around that, I just stripped it down to, hey, here's the homepage. Nothing a lot about it. And here is a way for me basically to do batching and basically return a JSON. So this is a single call and a single request. So it's really very easy for us to compare number of requests to number of returns from the server. So we have one-to-one matching. So you can see that you don't have to do some math about HTTP requests, and there are multiple HTTP response because of all the JavaScript and CSS and all that. So very simple. So I have this site. This one is running in Hong Kong. I have another site which is running basically in East US. If we look at the portal, which one is which? So if you look at the portal, this is I want to run on, let me go here for a second, it will be easier, west, east. So let's start with the Hong Kong one. Let's go to scale. And I want to set it to run on like 2 mediums, for example. Hello, today. Maybe not. Let's try, here it is. So let's go to 2 Let's go to a medium and hit the save button. Right, I'm doing the right thing, right? Yes. Okay. So he'll go and now he'll go and take two sites that have the sys1 site running on those two, and basically let's go up and touch it to keep it a little warm fuzzy. Hong Kong. Yeah, it will take a second because now it's .NET and it recompiles everything, but it will come back sooner than later and so forth. So in the meantime, let's do the one in East US. Actually, no, my bad. So the East US needs to be on 2 medium, sorry. And the Hong Kong one was on small, which was right. One small and this one we will scale. Okay, sorry. So we'll have the Hong Kong and we'll start with small, we'll move to medium and large. And we have the one in East US where we will basically have 2 medium and we'll hit it. If you look at the portal, for example, if you look at the monitor, I want to show you that I did some run testing as Chemtrade in the past, but right now there are not a lot of requests over here. There are like 12 requests. So we'll remember that because later when we'll see all the results, we'll be able to basically we'll be able to compare this to whatever run that we have. And almost nothing here. Okay, so what I need is a volunteer. Who's a volunteer? Anybody? Someone? I need someone to take time from me. Like every 3 or 5 minutes, remind me that I need to go back and change the scale for the site in Hong Kong to make actually the thing works. So going back, this is the Hong Kong. What I have here basically is I have a test harness, which I can share with you later. Basically, it's going to run for 15 minutes, 900 seconds. It's going to hit the Sudoku Hong Kong site, and it's going to pass basically those transactions one after another. I'm running on 100 virtual clients and going through quite a lot of traffic against this poor small site. I have 2 of those. I have load test 1 and I have load test 2, and similarly I have in East US, I have this one. This one I'm actually running 200, and there are 2 of them. And they're running against US, and they're running basically the same puzzle. Okay, so without further ado, let's actually start because we're running a little bit late. This is the previous run. We'll go over the number a little bit later. Okay, so I'm starting this one. Have fun, and at the same time, as you can see, you'll see in a second that the numbers are starting to show up. It basically says that this machine right now is going to provision a lot of traffic and a lot of open connections over here. And this means that we are driving a lot of requests, like 375 or 500 in a second, basically. I know it sounds a lot, but we can do better. So let's run this one, which is exactly the same thing, same configuration. Okay. Now let's run the Sudoku third one. Okay, so this run is running. I have my timer there, and every couple of minutes I'll go and change from small to medium to large, and we'll see where we're going. Okay, so took a little bit longer to do the setup, but hopefully it'll be better. So we're running the first 2. Let's continue. So this is the marketing slide I promised. I hope you've seen this in the past already. Basically, Windows Azure websites. It's a kick-ass platform as a service for modern web. It's flexible. You can run basically whatever you want. You can run .NET, PHP, Python, Node. We're working on some other stuff along the way. You can choose any database that you want. Just a regular website. You go in and deploy, and you have fun. Ready for business. It's a good marketing slogan. And scalable, which is hopefully what we're going to be able to see in the next 15 minutes, give or take. So it's a pretty powerful self-service platform for developers. And hopefully during the session, we'll be able to present some of those stuff. So what does it take to run a production site, actually? Well, it's not so complicated. You build it, you test it, you deploy it, and you maintain it, and that's about that, right? So if you want to build it, you can bring your favorite language, any framework or tool or whatever you want, right? As I said, we support multiple of languages. You can bring a third-party component and have fun with it. Visual Studio is a good integration. If you've seen through the demos, you've seen it in the keynote, you've seen it through other sessions, and so forth. Testing it, again, testing is a little bit maybe tricky or trickier, depends how you look at it, but you can test it obviously on your computer over here. And you can test it on some other places, like maybe you have a big server or a big box to test against your production, but it wouldn't be great if you can actually test it in the cloud. That will be awesome. And then you can, basically you don't have to manage multiple environments, and you don't need to pay attention exactly if this environment, does it fit production, does it not, is it the same configuration, and so forth. So we allow you with Windows Azure website, with today's announcement, basically to run in the same data center. You can run a free, a standard, and a reserve all in the same data center, so you can actually have your site, and you can run them and test them against shared, which is pretty reasonable. And then if you want, you can actually move your big workload into reserve. So who was my volunteer? Because nobody called for the time. It's 2:20 on this, so I have it over here. 2:30. We'll see it in a second. Okay, so deploy it. Coming to deploy a website is again with Windows Azure websites. You have multiple choice. You have FTP. You have web deploy, and obviously you can integrate into source control and you can deploy it from the cloud. The nice thing about it is when you deploy it, there is all kind of cool stuff regarding with production and production configuration and secret, which we'll see later in the demo, that if you configure the portal properly, you can actually have like connection string settings and all that in the portal and not in your source code or in the web config or anything like that. And then it's easy, and we do the meshing eventually at the end behind the scenes for you. So it's pretty cool to maintain it like that on the cloud and have your very clear separation between production and deployment. So it's now been 3 minutes, so let's go here. So we're on the 3 minutes mark on the Sudoku load test 1, which is not blue, which is good. You're seeing how much we are driving here, like about 100 pages per second on a small. Probably could do better. So Hong Kong, scale. What I'm going to do now is going to switch from small to medium, which will actually will drain all the requests coming from the small, and we'll move it to a new machine, which is the medium machine, and I'll hit the save button. What will happen, basically, if we look later at the test result, you'll see a drop in the stress that we are running, and you'll see it pick up again as there is more capacity we can run against. So if you look here, basically, you'll see will slowly start picking up because the number that you see here basically is an average across all the runs. So even if the next run is like really high, you can see it will take time to slowly creep up. But hey, we're running it for 50, 20 minutes, so we should be fine on that. Now that we're running on a medium, we can probably at some point add more load. Okay. So we'll continue. So the next topic on this slide is basically maintenance. And maintaining a website, I mean, building it is rather easy, kind of. Testing it's meh, okay. Deploying it, it's a pretty simple task. But maintaining it over a long time, monitoring, keeping diagnostic, debugging if something pops, all that, it's really an issue. So at the end of the day, if you look at the slide, if you want to build a production website, all you need to do is build it, test it, deploy it, and maintain it. Hey, what can go wrong, right? So a famous quote, anything that can go wrong will go wrong. Any idea who it is? Anyone? Murphy's, exactly. Murphy's Law, the first one. Okay, thank you. So continuous integration. Basically, it's this is like one slide and one demo, and there is another session tomorrow which we'll refer later. We have many source control options with Windows Azure websites. You got TFS, you got Git, you got local Git, you got GitHub, you got Bitbucket, Dropbox, whatever you want. And the idea is basically you work and whatever you save and you hit it and you push it, then at that point everything, the builds happen and you automatically get pushed your source into like a staging or a deployment environment, depends what you're looking at. So you can push it directly from the cloud. And during that, we have custom deployment scripts, which actually allow you to run whatever you want in between the steps when you're deploying. You can install stuff, you can run tests, and fail your deployment if they fail, and so forth. So with that in mind, I think I'd like to switch to a demo. Let's see how long we're running. OK, we can switch in between. So what I have here basically is a Sudoku. This is the source code for the Sudoku site that we've seen. And I basically want to add some more data to the index page to show me exactly the local time, the server name, if I'm running on multiple servers, so it will be nice to see those, and basically if I'm running on 64-bit or not. So I will do that, which is kind of nice. Another thing that I want to do basically, I have some testing with this project. Basically, is the Sudoku, which is the website, the open source that Adam downloaded basically to solve the Sudoku, the actual solver, and I created a small unit test basically to run some tests. So I have some tests, and I'm going to do this on purpose. I'm going to save it all basically. I'm going to do it on purpose because I want to show a point. Obviously, during normal development, this would not happen. Okay, so we have run enough time with this. You see the numbers are starting to crawl up. We were at 100, and now we're running a little bit higher. So it's time to switch to a large VM. Hit the save button. Yep. And while we do that, let's actually go over here. Let's change it because we're running a little bit late. So I'm adding more load to the first run. So I'm adding a second load basically to the run. Now 2 VMs are going against a single website, which is running on a large in Hong Kong. And as you see already, you can see higher number or the same. This is a new run. Okay, so back to the Sudoku. It's only about the jumping back and forth with all the demos. So we have a test we're going to fail, and we have this, and this looks good. And what I want to do basically is I want to go to GitHub, which is to my Git basically, which is one example of a source control that we support, and I want to do the following. So let's see first where we're at. Okay, so we are in the staging environment, as you can see. Maybe I should actually tell a little bit this. Okay, sorry. So I have 2 sites in West US. I have Sudoku Prod, which is running on standard tier, which is a reserve VM, and I have a Sudoku stage, which is running in shared. On the Sudoku stage, I got go to the config. I have configured in advance the site to point to basically a Git repository. Here's the Git repository, and I'm looking for a specific branch, which is the staging branch. On that Git, I have a staging branch and a master branch. What I'm trying to show is, hey, let's do some changes. Let's push them to staging branch. Let's see how they react. Let's test it, and everybody feel good about it. And when we're happy, we'll just push it basically to the master branch. Okay, so if I go to deployment, let's actually see them. So I have 2 files. Actually, I just need to check one, but let's do them both. I'm going to just use this because it's Git GUI because it's a little bit faster. I don't care for this. Let's test the unit test first. Basically said setting up demo to fail. 1 commit, and I can go to the other Sudoku, and basically this is adding more data to the first page. Hit the commit. Cool. So while I'm here on the deployment, I'm gonna hit the push button, staging. I'm gonna hit the push over here. Either it's gonna ask me for password or not. Super secret password. So it's gonna push. It pushed into the stage, and soon basically we'll see the deployment being refreshed automatically, and we have pushed it. Then basically we're running the deployment command, which is basically getting all the stuff building, and soon it will run the deployment script, and hey, it failed. Any idea why did it fail? Anyone? The test, exactly. So let's see it actually, how does it work? Look at the logs. So this is a command. I show you. This is basically running deploy command, deploy CMD. I'll show you in a second. Let me just scroll all the way to the end and basically shows you, hey, the search failed. You had 2 tests, one of them failed, and so forth. How does it look basically? If you look at Sudoku, if you want to do that, basically there is somewhere a blog that I can point you to, where basically it will set up everything for you. And it will set up the deployment file, and will set up a deploy CMD. And then if you look at the deploy CMD, this will give you a bunch of stuff that you don't really care for. What you do want is, there's a lot of setup in the front. What we do want is basically look at the deployment script. So the first one is basically building our project, the Sudoku itself, into a temporary folder. Then we are actually going and building the test. After that, we're running our tests. And here's where we are failing. And if everything succeeds, then basically we are doing a sync, and we are copying from the temporary folder from stage 1 into actually the production. This is where we are actually switching in live. So this will give you confidence, and you can run stuff. And you can do whatever you want here. You can install component, you can download dynamic stuff, you can get stuff, you can do whatever you want. So with that in mind, let's go back to here and fix our test. So it passes. That was easy. Let's close this again. Okay, so basically, yeah, I can do git push, but this will be easier. And again, I'll show it to you. So basically, this one failed. I'll go here, I'll hit the push button, push. Okay, so it's going to push that. It's going to go over there. It's going to start the deployment to make sure, because I know this one actually is going to be successful. Let's close this. Let's do the integration already. Merge staging basically back into the master, and I'm just going to push, because they're in the same line. Shouldn't be like add or commit or anything like that. Before I do that, okay, so this is stage. If I go here, you'll see basically the new app running, and here, voila, great. And if we go to prod still has an older deployment. You see earlier from this morning, when you from browse, it's the old one. Okay, so let me just finish this. Sorry for the typo. Okay, it goes into here, goes into production. Basically, it will get here and will get updated in a second. Here it is. Okay, so, and we'll see this. We'll refresh, and voila. So we've seen how we actually took it from staging. We did some testing analysis and worked on that, and then we pushed it all the way into production. And now we have the same site and 2 branches, and everybody happy about that. Okay, so that was that demo. We did that demo. If you want to see more of that and a lot more, I suggest you go to Corey's session tomorrow. He'll talk about continuous integration within the Azure website. He'll show a lot. He'll show everything: TFS, Git, on-prem, from the cloud, bunch of stuff. Great session tomorrow at 9. I've never seen it before, but I'm sure it's going to be a super good session. Corey is a great speaker. So monitoring diagnostics. There are a bunch of stuff that we can talk about here, but I'd rather show you most of that, so this is going to be a quick slide. It's kind of loaded, but it's okay. By default, we give you CPU, we give you time, performance, we give you counters, we give you a bunch of stuff regarding the request, network that transfer storage size, and so forth. Something that looks like this, basically. We provide HTTP logs for diagnostics, and you can do fail request and tracing, and you've seen the application the application logging and tracing earlier in today's keynote. You also have seen there is a way to do availability check with the endpoint monitoring. So if you have your site, you can set up a probe that will ping it every couple of minutes and check how if your site is available or not in terms of performance and response and all that. And there is a bunch of DevOps stuff for diagnostics tool. Application and tracing you have seen, but there's more. There are memory dumps, there are diagnostic console, which I'll show in a second, a new relic, which we'll see later when we go through all the scale demos. So you have seen the application tracing. I'm short on time, so I'm not going to do that. What I do want to show you is something else. So basically, this is another Sudoku test site that I have. Here it is. Another Sudoku test. We have a bunch of those. If you go ahead and add, I don't know if a lot of you are familiar with that, but you can add SCM for Source Control Manager. And this will load what we call the Kudu site. And this Kudu site, basically, it's been there since pretty much we deployed and we released we released Windows Azure website into preview last year. And you can do a bunch of stuff, like you can do your runtime environment, which basically gives you, this is the app settings that are in the database runtime of if you configure the portal, you can configure parameters. Those are the app settings that in there. Here's the connection string, again, not really using it, but this is all coming from the database of the portal, not necessarily your code. And when we basically bring the application into runtime, then you can see the environment variable being fused together. And you get a bunch of stuff here. You got like the directory that we are running and compiling into. You got some other more like interesting stuff, like in terms of the program filing, what you're running for, which version, which like is 30-bit or 64, you can already know that, and so forth. And there is more interesting information over here. And these are all the headers that we are setting. So this is kind of nice. Log streaming is just the log streaming. It's basically keep polling and showing the log. And there's another cool stuff, which is this, which is kind of a console. It's not exactly a console, but it's kind of a console. But I can do there and see my site. So this is the site. Hey, I can go into like, let's actually go to the site itself. I can do there. Here's the site. I can see my deployment and my diagnostics. I can actually go into my repository. I hate typing this. And I can do this, and there's not a lot over here, but there's a lot of stuff that you can actually do with this tool. And what I want to show is actually go ahead and show even a newer version of that, which we have not yet released publicly. So it's a preview doing RGA, which is kind of nice. Tribute. So this is the next version, right? Remember the Kudu that we've seen so far? Sorry, this one is 0.22, and this is 0.3. All right, so basically you get some bunch of stuff here. We added some APIs to, if you want to see your app setting in an API version, you can actually see that. If you're looking for process and mini dumps, you can go ahead here, and you can see a current view of how many enders are open, what exactly is running, CPU, and you can click one of those and to get like a mini dump, which will get a current dump of your application right now if you want to diagnose some long-running stuff. Another thing I can do is launch the console, and as you see, we revise it a little bit so it looks a little bit better. I can actually go into site, and there's autocomplete, which is kind of cool. I can go into the repository. I can do like do git log. Will get me like the previous 5 Git that I did. I can do tail to the license, for example. and it will run tail. And you can run a bunch of stuff. I can actually run PowerShell commands to show me all the processes that are currently running. So there are a few restrictions on this. You can't really run anything that is interactive and so forth, but it's pretty cool. But you can go into your repository, you can fix your repository, you don't have to FTP. You can use this dynamically to go and manage files and see if you can there read the files and so forth. So it's rather nice to have that capability. So this is, the previous one is already out. This is the one we're going to release in a couple of weeks. Yes, nobody is from the portal here, right? All right. So half of the session is done, and now I think it's time to actually talk about scalability. I think all the demos are done, and we'll be able to see them in a second. So scalability, this is a courtesy of Wikipedia. Scalability is the ability of a system, for our purposes of this presentation, it's a website, to basically handle a growing amount of work or HTTP traffic in a capable manner, where I translate capable manner into something that doesn't go belly up when you push the crank against it. And basically be able to handle all the load and all the scale and so forth. So for website, if you want to do scale, basically you want to get more throughput. If you're looking to achieve high availability, and you're trying to do it through scale, basically high availability is maybe a byproduct of scale if you add more instances, but it's not necessarily the same thing. So scaling option in Windows Azure, you can scale up. Basically in standard tier, you can switch between small, medium, and large VM, just what we did with the demo, and we'll see the result in a second. And you can scale out, which basically allows you to add more instancing. In standard tier, you can add more VMs. In shared, we basically run the same process, or run your application on a separate process on separate machines, basically, in the shared environment. I think that our demos are done, and so let's go and see the results, and hopefully they are satisfactory. Okay, so the run is done. The run is complete. This is Sudoku number 1, as you see. Managed to push about 153,000 requests in those time. Remember, we moved from small, medium to large, so this is on average. So on average, it was 170 requests a second, but because we moved from different VM size, overall, we managed to push 153 on this machine. And we have another machine, the number 2 machine, and this one managed to push about 170. Any idea why the difference between them? Quick, anyone?
You didn't scale the first one?
Correct. So the second one actually started a little bit late, and I was already enlarged by that time, and so forth. And you can see basically that the page per second is a lot bigger. Again, because this tool averages across all the time. And by the way, there are no errors at all, zeros on the errors. And I'm going to ask why there are no errors, because these numbers are impressive and something doesn't add up. So 153 plus 170, quick, how much is it? Anybody? I'm struggling here. So this one is, the first one is in Hong Kong. Over here. So I believe if you do the math, you'll get to 320 something, which will be around 320, 325, give or take. Right? Plus, minus. And it's not that bad. If we look at the other run that we did it in East US. And I believe you actually see even a higher number of almost 500,000 requests within those 15 or 20 minutes that we have run our test. And there are 0 errors, or supposed to be not a lot of errors. Where's my error counter? No, it's there. Or it's, 0 errors, yes. 0 errors. And again, if we look at the numbers, we'll see basically the numbers do add up. This is blue one, so it's 231. And if I looked at this over here, you'll see 233, so combined together is 460, give or take. Hey, 500,000 requests in 15 minutes, not that bad, right? From two different machines. Pretty good. I wanna show you how does it look in terms of I've enabled New Relic on those sites. So if I'm gonna look here, make it so what I'm looking on. This is the wrong one. Let's look at the one in Hong Kong, which we actually switch between small, medium, and large. So you can see here the run basically we ran a little bit before 4, and it's running. I shouldn't have done this. Not now. So the run starts. You see numbers here. You can see the average basically. This is the average across all the time. What I want to show basically, as far as the servers, you can see there are 3 different servers here. One of them was the small, one of them was the medium, and one of them was the large. I think you can actually see which one of them is which. And you can see that basically CPU usage starts and ends, starts and end. And the reason it's so abrupt in between is because I didn't let the test basically run enough time on each machine to actually pick it up. But as you can definitely see here, the CPU goes through usage. You see CP this is the last machine, the way you know it. This is the large because it has 400% on the CPU, which represents 4 cores. You can see the memory nice and climb nice and easy for this as it runs. And then the throughput comes about a little bit later. I think there's some issues here with the New Relic agent, which basically just report a little bit after everything. But it's pretty much, trust me, if you run through all the numbers and you see all the averages and you look at the time, basically you get to the same numbers that we have seen in the tool. I will mainly use the New Relic to show the CPU and how distributed does it go. If you look at the one that we did in East US, this shows a lot better in terms of the way that we distribute the load. You see each machine pretty much have the same RPM, request per minute, like all the machine in terms of load and balancing between them. You can clearly see the CPU goes up. 2 of them are a little bit higher than the other. I can probably explain this in a second. But you can see memory goes up and stops when the CPU stops, and the memory stops climbing when the CPU stops climbing, and so forth. And throughput keeps up, and a little bit after the test, the throughput kicks in and continues again because of that bug. Okay, so with that in mind, we have 22 minutes, and I have about 30 minutes of content. So let's go back, because we have 2 more demos that we need to run. So we've seen those. We've seen how you can scale up and you actually get more requests coming in. You've seen how you can scale out. And again, if I can share the base number, and you can see that the scale is pretty much linear in those respects. So we can run 32 bits versus 64. Those are applicable today only for .NET application. From the testing that I've done, you can get about 20 to 30% gain. What you need to make sure is that all your dependencies that you're deploying and installing with your application actually support 64 bits. If not, then your application will probably fail to load. There's currently no 64-bit support for PHP, Python, or Node, and we are working on that, and you'll see it in the near future. So we've seen the scale. Let's actually go. I want to talk about how the system works, but before that, let's just go kick in the other demos. So other demos, which will be done just in the nick of time for those. Okay, leaderboard. So I have a leaderboard demo, which is I want to show exactly for a second. The leaderboard demo is very simple. This is a scale out session. Basically, it's a cold site right now, so it gets a second to warm up. But this is a site that is very simple. Here's the player ID, and every time refresh, the same player ID comes back, and the player ID basically come back, and there is a number of tries that the player have come in and played. And every time he comes, we randomly get a number for him, and then we add it to the total, and this is the score that he has. And I run the request on the 7th time, 10 times. On the 11th time, what we will do is basically invalidate that session, that cookie, invalidate the user, and generate a new user, and with a new number, and so forth. The reason I did it is basically those are like, you can imagine those are, the users are coming in like shopping cart or are coming for playing a game and so forth. So they can land on any machine if you have scaled out, and you need to maintain their session somewhere. So we're taking the session, we're tracking the session with us. If you go to the leaderboard, you can actually see the numbers and results here. This is the previous run. We'll click the reset score in a second, and I only pushed about 86,000 games in about 10 seconds. Nothing serious. Let me reset the score over here. Good. So this is the leaderboard game. The other thing that I'm running right now is I'm going to run in West, which I need to go to Sudoku test, scale. Let's start with 2 smalls. Okay. The leaderboard is in Hong Kong in terms of scale. We're drawing on 3 million or 2, I can't remember what I want to set up, but hey, it doesn't matter, 2. So for the load on the load that runs in Hong Kong, I'm going to go over here. For this one, instead of using the test harness which WCAT, which we ran before, we're going to actually use Visual Studio. And Visual Studio comes with a web load tool test. I'm not sure how many of you are familiar with that tool. This is again a previous run that I made before on the test. So I have 100% of a test basically, and if we look at the test for a second, it basically go to Sudoku test and run a puzzle. So multiple puzzles here because actually we are trying to make the machine work harder, but that's okay. This test will start with 2 smalls and somewhere in between, and we'll add actually 2 more. So we're trying to scale out like we're doing with autoscale. So let's go ahead and make sure that, again, if I want to make sure that you guys are going to believe me when I run this, so 2 small over here. Let's see on the monitoring, for example, that there are 0 requests right now on here, and if I go to Sudoku test, there'll also be 0 requests. So whatever we push, it's a new. Let's go ahead and make sure that those sites are running, so they're hot for the test. Otherwise, it will be just the first few seconds will just take a little bit too long in terms of, and it doesn't look good on the test results. So this test is going to run for, I exactly don't know how long, but I hope we have enough time to review the results. 15 minutes, and we have 17, so it should be fine. You'll bear with me, right? And we want to go here. Blue one. Or here. Wait, I want to run the other one. Oh, sorry. A little blackout. So, again, my bad. Wait. Which test are we running? Leaderboard. Yes. Okay, so we're going to run this test, the Web Lotus test, and again, 100% of this. Check that. This one will be 10 minutes, which is a little bit better. Okay, run. So 5 minutes from now. Okay. Okay, so back in business. If someone can remind me 5 minutes from now, it will be super great. So the test that we were running is we're running a run on 2 smalls, that one, and we're actually going to go to 4. And this one is basically we have 2 mediums, they are running, and I'll show how you can actually manage the state and everything is working. So while the 2 of them are running, we can go and see the leaderboard, and the leaderboard will get basically updated as the run happens. Did I press the button? Got some errors here on the run. Let's see. I guess I'm not seeing what I'm doing. So 2 medium of flight running. Okay. Should be fine. What's wrong? Okay. Come on, come on. See? That's what happened. We're going to give it 1 more minute and it should work. And if not, I'm going to show you a Martha Stewart trick because I'm actually going to show you something that I already prepared in advance. Failed. Why did it fail? Oh man. Okay. Let's just give it a try. Let's see what happens. If it's going to work, fine. If not, we're going to see, we're going to look at a slide that I prepared in advance. Okay, so how this thing works. We can talk a little bit about how does it work in cloud and the fact that we have this database behind the scene to merge all the dynamic content and settings and basically dynamically provision and run the site and so forth. But better just to show it. So a request comes in, hit the Azure Load Balancer. Basically, it goes to the front end asks itself, hey, do I know this site? And if I don't know this site, I'll go to the database and ask, what do I do with this site? Database says, hey, here's a worker for you. Go run on this worker and have fun. Workers come in, basically provision dynamically the site. Site get provision, go to the database, get all the data that he needs, all the environment variable, everything that I've shown you before. We set up the site on the worker, whether it's a shared worker or a reserved instance, it doesn't really matter. Picks up everything from the database. This time it's the user database, if it has one, and then continues. So if the same site comes again to the front end already know this site. This time it's not going to ask anybody, it's just going to redirect. And this is how it works. So behind the scene, we're doing the smart load balancing. When everybody talks about all this load balancing, this is what happens. But you need to understand a few things with how this works. So if your app is a stateful app, okay, then you need to meet someone called ARR cookie. And the ARR cookie looks something like that. We'll go here. Oh, here, now the leaderboard is running. Okay. Oh, well, thank you for that. So this is the leaderboard game. I don't know what happened with the test before, but now it's a little bit better. As you can see, games are running. 6,000 games already. Okay. So we can use it even here. That's fine. This will refresh as we talk. So if I click F12 first, I can see network traffic. What I show you is resource, and I want to go to cookies. If this is too small, I can actually zoom in. But what you'll see is we have few cookies here. One of them is the ID that this is the game. There is another one that we can talk about a little bit later. But there's the error affinity cookie, which is basically the one that binds the current request that came to a given worker. And if you have 6, you'll still go to a given one if the cookie presents itself. Okay? So this is the error affinity cookie. And you can look for it any request that you're doing. So if you're a stateful app, that's good. If you have a single instance, you're happy. If you're scaling for small, medium, large, you're happy. If you're running on few instances, the error affinity cookie will try or will make sure that all your user or your current user within the session will be affinitized to that machine. If you're running an in-state, in-memory, and all that, then you're good to go. However, if your app is stateless and you want to scale out from that perspective, you need to say goodbye to the error cookie. And you need to remove it. Unfortunately, we don't do it for you right now. So your way to do it is from the client code, something that looks like this. Just kill the cookie. Your NAC request will come in. Basically, it doesn't mean that the front end will always go to the database, ask what to do with you. It has enough information about which worker is to assign. But you will get assigned to a different machine if you have multiple machines. Depends on some different algorithm, but you will not be affinitized. The problem with affinitization is one of the run that will end shortly after the session ends. But we will see that still. You'll see that the numbers differ. Oh, and actually, let me go here. Completely forgot. Where are we running this stage? This one on 2 smalls. Let's bump it up to 4. So what I did is just trust me, I added 2 more cores to one of the tests that we are running. 2 more machines. So if you are managing your state, if you're responsible for the state, whether you put it in a cookie, you put it on a cache, you put it on Azure storage, you put it in a database, I don't care. If you are managing your state and your app is stateless and you can guarantee that, then you want to make sure that you get rid of the ARR affinity cookie through client code for now. And in the future, we'll add basically a checkbox saying, hey, affinitize me, yes or no. And then you need to manage your load across all the components, right? I can provide you like with 10 large machine, which is 40 cores. And as you can see, the numbers are pretty impressive, right? Even with 3 or 2 mediums, we will manage to push 500,000 of requests within 10, 15, 20 minutes, right? So with 40 cores in a single data center, you can run a lot. So even if you do, you need to make sure that your database scales, whether it's a database, whether it's MySQL, Azure, MySQL, Mongo, whatever, and any other third-party component that you're using, service bus, any other service, external service, and so forth. We've seen the deleting cookies. We've seen this. Let me actually go through the slide, and then we can actually see the data. So autoscale, we've seen there was a demo of autoscale, or there was shown the UI of the autoscale. Autoscale basically is optimizing your cost. Everything that we've talked to here about how to scale and the fact that Windows Azure websites scale to a very big and large or very large number of HTTP requests, all that is all good and true. The autoscale will just optimize the cost for you. Instead of running with 3 medium all the time, you'll run it when something happens. However, if you are running through scale out and you don't get rid of your AR affinity cookie, it may not work as expected. And we'll see it in the results of one of our run. And scale up will be coming soon as well to the auto scale part. So there are some additional scale consideration and topics I want to cover. Cache, for example. So in-memory cache, like Memcache, it's all in memory, but I'm saying in memory because Memcache by default doesn't come in a distributed manner. So guys running with PHP, with Memcache simply use that for speeding up stuff. Cache is another way, a great way to gain more performance of your application, especially if you're doing database and all that, and session management and so forth. You can have distributed cache, like Velocity. You have cache as a service, like happened in Windows Azure. You can have all of that. Today, with Windows Azure website, you don't really have a good caching story. We're working on that. We're working hard. We'll be there, but not today. Geo-distributed. Basically, you can run your sites from multiple data centers. In East US, in West US, in one in Europe, one in Hong Kong, doesn't really matter. You can stick Azure Traffic Manager on top of them, and he will do the traffic shaping for you. There is a way to do it in Windows Azure website today. It's a hack. If anybody is interested, let me know. But even with that, again, you can scale through a lot. CDN obviously it's not really about scale, but it's a lot about throughput and a lot about goodness that comes with that. So obviously, if we have CDN, it's good. We don't have built-in CDN integration right now with Windows Azure. We will with Windows Azure website. We will pretty soon. And then we go to even more advanced topic like sharding. You can shard your database, whether you do it manually through your code, or you're using database like Mongo, for example. Traffic Manager will shard your traffic across. You can have advanced load balancing if you want to have like, hey, 5% of my traffic goes here, the rest goes there, even within the same data centers. We don't have all that right now, but if you really want to use that today at Windows Azure website, let me know, because there are tricks, actually, you can do it. And any other application-related sharding logic that you can think of. The reason I'm showing this slide for all the things that we don't really support within Azure website today is because we have a lot of customers. We have over 90K subscription. We have over 130,000 websites. We have some nice name. I can't really mention all of them. But the thing I want to show is this, basically. This is a graph of traffic comes to the site called Beauty of the Web, which is the orange line here, which drives about 16 million requests a week. Okay, so a little bit of over like almost two and something every day. And then there is this big site, which I can't really tell his name. I can tell it's a game. It's a Facebook game. It's about 6, 7, close to 8 times more. Okay, so what I'm trying to say is, and these are just 2 examples. These are not even the largest site that we have. Just 2 examples of websites that are running on Windows Azure website today. Not running 10 larges, running only a few smalls or few mediums, as you've seen through the data that I'm going to show in a second. And even without caching and without geo distribution, without a bunch of stuff, traveling about, the blue line represents about 100 million requests a week, give or take. Not that bad, I would say. So, if you don't believe me, try it yourself. All the code that you've seen here, the leaderboard, the Sudoku, my test scripts, everything is accessible through these links. The Sudoku game, the leaderboard, both of them has the scripts. If you want to run the tool itself, the WCAT tool, it's through these links. I'm going to blog about this as well. This is my Twitter account. Please do try this at home. Now, there is another slide, but let's actually go and see if our test has completed. And in this case, we'll actually be able to review. So this one is still going, 5 minutes, quite a lot. But as you can see, there is about close to 60,000 tests, which is page request. And this actually has a lot more HTTP requests because the leaderboard is actually a website and pushes a lot more traffic. So it's about 60K requests right now. Let's see if the monitoring agrees with us. Let's go to the leaderboard. Where's the leaderboard? Where is it? Leaderboard. Let's go into the monitoring. And this is about 25,000 HTTP requests came in through, 24/7. You look at here, 25.1. Okay, takes some time to catch up and so forth. But as you can see, numbers are kind of aligned. If we go to the other test, which one? This one. This one actually completed, which is rather nice. So this is the one which we run with 2 small, and then we increase into more. And we pushed only like 77 requests on a given time. And this I just wanted to show this. So I'm going to run a little bit over. I hope we're OK. Give me like 2 minutes, and we'll see this through. So if I go to, I can actually see the data of the numbers here as well, because you can see the number of games for the leaderboard. So this is how many games that we've played, 68,000, right? Remember, it was 60 a couple of seconds ago. So if I go to a New Relic for this, let's go to Sudoku website. This is the site that I have run the test where I started with 2 machines, and then I added more machines. And what you can see here is exactly the affinity cookie that I was talking about. I added the machine a little bit late, or a lot late, actually, as you can see from here. No. This is not what this is a little bit too aggressive. So let me show you from the run that I've already have. I have backup slide basically of previous runs. So this is the run that I ran running from, this is the one, right? Yes. 1, 2 smalls, add to the 4, overall 94,000 requests to the load to stale. If you look at over here, you see that this is the run, actually this is the run I made like 2 hours ago. You can see the difference, not that big, in terms of how many requests we pushed through the tool and how many we actually got caught and everything came okay. What I want to show is this. This is the run that actually shows 4 servers. They're not all starting at the same time as you see. The green and the green and the kind of yellow, blue, sorry, the green and the other green started a bit later. But as you can see, as you can see through the CPU usage, they're not all equal, and the throughput is not all equal, and the usage is not all equal in terms of running this, and the memory is not similar. And that reason is exactly that error affinity cooking, is because what you're seeing here is that all the requests basically came in and wasn't distributed well. Now, you guys should be saying, hey, something doesn't really adds up here. You're lying, and I'm lying, but only a little bit, like really, really a little bit. And the reason that I'm lying a little bit is because I have set up some of my tests, for example, like this one, to have 0% of new user. So all of the users, all the traffic is existing 200 clients that are running multiple threads at the same times. Okay? If I would change this a little bit to show something else, let's say 30% or 40% of new user, then you will see different result. And if you don't believe me, I will just happen to have one here, which is running the loader, the leaderboard game. And this is like only 35% of the requests are new. So this is the ratio. And this is enough basically to spread the load across because they are churning, right? This is 35%, but it's like a sliding window. So you always get constantly newer requests. And if you look at the leaderboard, you'll see that the distribution here is a lot better, a lot better. At least 2 of them, if not all the 3 of them. But hey, 2 is enough. Maybe I'm not pushing enough data through the pipe. As you can see, average request per minute is pretty high on those runs, like 10,000 requests. I can actually go back to my leaderboard game, and this is how many games I'm actually pushing. So this goes directly against the database, right? And you think maybe I've done something funky stuff with the database, like we're almost at 100,000 requests. No, the leaderboard games is super dead simple. This is it. This is get the user, get the session cookie, get it from the database. I'm actually doing another count to get the count number, how many times. Not using stored procedure, not using anything fancy on that. Just to show that the scale of your website and the database, if you combine them together, can actually scale to that level. Okay, so there are no tricks here within the database or anything that goes beyond that. Reset the score, there is an insert, very simple. Again, no stored procedure. And behind the scene, we're just doing a calculation of everything. So basically, every request translates into 3 or 4 because I'm taking time. I'm doing a statistic for database. So every request is actually 4 requests to the database. So we have 100,000 page views. We have 400,000 requests on the database. Okay, so with respect to time, let's just see where we are. It's almost at 400,000 HTTP requests. With that in mind, and only 5 minutes beyond, let's see where we're at. So almost all the demos make it, which is not that bad. We've been here, we've been here, we've been here, here. Okay, so why do you want to use Windows Azure website? I think because it's kick-ass. Okay, it's kick-ass with everything in respect to everything that you have. It's kick-ass with scale. It's kick-ass because it's open and flexible. You can run whatever load that you want on it. It's good for business. It's world scale, worldwide, integrate with Visual Studio, and everybody happy about it. More sessions, and I'll return to this slide if anybody wants any Q&A. Thank you very much for taking the time in 5 more minutes. Oh, and please, yes, scan this QR now and say this was a wonderful session, like the best you ever seen, and scaling is amazing. What? Kick-ass, yes, kick-ass, kick-ass. If you have any questions, I'm here. Thank you very much. And this was a team effort. So we got 2 team members here, Nir and Hussam. Thank you very much. Everybody are happy. One demo blew up. Oh, man.